Okay, here's the, we can record. Welcome to Expert in the Room, last day of the DUNE Computing Training May 2021 edition. And Tom is going to guide you into how to modify a LArSoft module, starting with VNC tips and tricks, right?
Yeah.
Thanks.
Well, since I had already made the video for the exercise, I was wondering, whoops, I shouldn't show the quiz. I was going to answer questions for the exercise. But I see that in the Google Doc, maybe I should answer Google Doc questions here. Someone was saying that the event display was very painful and that you should run VNC. And I think I've got things in my setup that are not very private, so I can go ahead and share that with you. So they found the instructions right here, and these are essentially the instructions that I followed to find these aliases. And if, oh, this page has moved to the DUNE wiki. Someone found that. So let's go to the DUNE wiki and use those instructions. It might be under interactive. Computing resources, VNC, better X window connections, and then there's this page.
Just to have an idea, can people thumbs up if you have access to the wiki and thumbs down if you do not have access yet to the wiki, so that we know a bit where things stand. Thank you.
Right. So what I do is I essentially just follow these instructions here. So on the DUNE GPVM, you have to set up the session. Let's see. Yes. So this grabs number 61 for VNC server. It sets the geometry for something that works well on my laptop. And that's this command here. And I just have an alias for it. And then on the local machine, I've added this to my .ssh config in my home directory. And the question was, is this okay on Mac, not Linux? And it turns out that this works on Mac and Linux because Mac has Unix directories and SSH. I'm not sure how to do this on Windows. So if anyone has their own Windows, I have no clue. But you add this to your SSH config. I've got a few of these. It's best to be a little bit defensive here because the DUNE GPVMs can gum up. You remember the discussion on Wednesday about not using the NFS mounts to decache because that can gum up the NFS server. It turns out sometimes we've seen load averages get as high as 40 on some of the DUNE GPVMs. And if you're running your VNC session on a DUNE GPVM that someone's doing HAD on decache and gummed it up, then your VNC server session will be very slow. So it's good to have several so you can duck away from one of those DUNE GPVMs and go on to another. I've got two of them chosen here. And then there's my own desktop, which is an ancient PC sitting on my desk over at Fermilab. So I mostly use my own desktop because people aren't using decache and it doesn't even have decache mounted. So the VNC sessions are nice and responsive. So then what I do is on the GPVM is I execute this alias command here. And then on my own laptop, I actually renamed this to FW DUNE 02 and FW DUNE GPVM 09. So that way I can SSH into these computers without forwarding the port. So what this does is it just forwards one of the port numbers, and that's the 61 that's in the, that has to match this 61. And this number, I think the 5901 is just a local number, so that you don't have to worry about colliding with other people, but the 61 has to be unique. And when you start up the VNC server session on the GPVM, you have to choose a password. It's not particularly, it doesn't have to be particularly secure. That's just to keep you and other people's VNC sessions from colliding with each other. It turns out that this thing, localhost, means that no one can just SSH into your VNC session without logging into the computer. So Fermilab's computing policy says you need Kerberos to log into a computer. And what VNC server does is it opens up a port where if you don't say localhost, it'll let people log in with a username and password. And there are port scanners that run at SCD, and they'll shut down computers if they see anything that allows username and password logins. Everything has to be done with Kerberos. So if you omit the localhost, a cron job will kill it, and that might even shut down the computer, and no one will be able to use it. So please just cut and paste that or put it in an alias. So that way, when you use this session, you actually have to SSH in. I SSH into the special FW DUNE 02 for my laptop, or FW DUNE GPVM 09. So this name is not the name of the computer. This is the name of this line in your SSH config. And that forwards the port, and it tunnels it over the SSH, meaning that that password that you chose is only exposed to you and anyone who can SSH into this computer. So it's not open to the whole world. So that password doesn't have to be particularly secure, but you have to remember it, and it's only for your VNC server session. If you forget your password, that is, don't write it down or whatever, the VNC is a hidden directory. Oops. In your home directory, it's .vnc, and that has a encrypted version of your password that you had chosen. And if you forget your password, there's no way to unencrypt it, but you can just delete it. You can remove everything in this directory and start fresh, and it'll ask you for a new password. So it's pretty harmless to forget your password on that one. Just delete that stuff. And it's also recommended not to start up lots of VNC sessions on the same computer. You can reconnect to one that you disconnect from. So if you just shut down the screen sharing that is started by this open statement on your laptop or your local computer, if you just shut down the screen sharing session that you start with that, your VNC session is still alive, and you can just reconnect with this same command. You SSH back in and reconnect. So I reuse the same session over and over again. So that's how to set up VNC. You're running a program in the debugger. Oh, are you trying to, oh, you didn't, okay, that's a different question. Someone got a install error. You might have run out of quota. You may have to put the full error message here. So this is in the build step. And if you use the build command that's in this script, it's got 16 simultaneous cores. So the -J16 says that make is able to launch 16 build steps all at once. So what can happen with this is that the build can get ahead of, or the messages can get ahead of what actually caused the problem. So it's got a counter that counts how far it's gotten, and it may run into a problem, but it's got 15 other cores that are still working away. And the problem may have been back at step 58% or something. So you actually have to scroll up and see where your error is. So there's more to it. If you've got a color option on your terminal, usually the error messages are printed out in color or in red from the compiler. So you may have to enter more errors here. In fact, that's some of the advice that we give to people before they talk to experts, is make sure you give them a complete error message. because we can't tell from the context if there isn't enough information.
Tom, you might remind people that the normal GPMs, not the build GPMs, only have 4 cores. So 16 is not a useful thing to do on those.
Right. Yeah, we mentioned that yesterday, but that is more than worth reiterating. So when you log in, whoops, let's log into a build node here. My bottom left screen is always reserved for the build node. And when you log in, it tells you how many cores there are. And here's my GPVM, it only has 4, and the build node has 16. And this was optimized a long time ago. Lynn Guerin ran LArSoft builds with different numbers of cores and figured out that with the setup with the disks that we had a few years ago, there wasn't any advantage to having more than 16 cores because then they were limited by disk I/O. However, the disks have changed, and this was before we even had CVMFS. So it turns out that now, I think there's more benefit to a bigger machine, but this is an old build node. We got 16 core build node when we asked for it many years ago. We got another one. And I think the other reason why we have only 16 cores is because that's all they had available to give us.
The temptation sometimes is to try and build things on the non-build nodes, and those only have 4.
Yeah. So it'll be 4 times slower, take 4 times as long if you run on a machine with just 4 cores. If you say -J4 or -J16, the amount of CPU is about the same. But there's actually another issue, and that is the build node has 31 gig of RAM, whereas a DPVM only has 11.6 for 11 through 15 and something like 10 for 1 through 10. So you'll run out of memory if you do that on a GPVM and launch with J16. So you launch 16 copies of the compiler plus whatever CVMFS needs, and the computer will most likely run out of memory. It won't kill other people's stuff, it'll kill your stuff. So that might actually be what happened. You get a signal killed, and it might have been run out of memory. Were you doing this on the build node? Oops. Yeah, okay. That's called the UNE killer. Or out of memory killer. And I never know what the logic is. In fact, it might kill other people's programs. It shouldn't if you're the one causing the out of memory problem. So you can, or build with -J4. Build with -J4 on a GPM, but it'll be slow. Okay, someone had no problem with the debugger. That's nice because I always have problems with the debugger. Okay, very good.
I want to thank the participant to show their errors so that everyone learned from them. Thank you.
Okay, I think we got another error here. But the actual error is way upstream of that. So this is a running feature of particle physics, is that we don't own our computers. We borrow them from other people, and we take what we can get. And they don't have a lot of memory or a lot of cores. That it's nice of the SCD to give us build nodes. And the same is true with the grid. We don't own any grid nodes. So when I sometimes read documentation on the web for things like organizing large processing campaigns. We're kind of special in particle physics because we don't own the computers and we can't install software in computers. What we do is we use CVMFS, which mounts a local or locally caches software. But a lot of people assume that you can install software on the computers that you're running on. We can't. Now log on to a DUNE build node. SSH 2.0.2.f node. Build 01 F node. You can run top or htop. See how busy they are. And go to the other one. Busy. We used to have, we used to have a automatic selector for the GPVMs, which would look at the load average and SSH in to the least busy one if you SSH'd into a generic point. So that's the way LX Plus works. It didn't work all that well. And to be honest, sometimes load average can be a little misleading anyway. If someone gums it up because they're accessing Bcache over NFS, the machine actually kind of works. If someone's running 4 CPU hungry processes on a GPVM, then it will be slow. But if someone got 4 HAD jobs stuck or 1 HAD job trying to read 4 files, the load average will be 4, but it won't be doing anything, so you can still use it. It's not as responsive as if someone hadn't done that, but the machine is better than the one that's actually computing something, if you want to log into it. It's typing their errors. Should I show how to debug a Segfault?
Let's see if we have some thumbs up on it. So that's okay. On the debugger Segfault, who wants to have a demo? 1, 2, 3. Okay, some thumbs up. So they are still there.
Yeah.
Let's go for it.
Got half an hour here, so we've already we tried to unstick the people who are stuck.
Yeah, that's the point. And so far, how do we log into DUNE? Okay, yeah, this has been solved.
So I have to create a Segfault in the first place.
Perhaps, Tom, can you remind the people, especially those new to programming, what is a Segfault?
Yes, I was going to show them. I have to create one and then show them what it is. But I can tell them what it is while I'm setting my environment up. It's an invalid memory access. Because we share these computers with everyone else, we don't want to overwrite someone else's memory. We don't have any secrets on our computers, or you shouldn't store secret information anyway, but there is memory protection because we use the same operating systems as people who actually do have secret information. So at the very least, we want integrity in our calculations. We don't want someone else overwriting our memory with their process that can't control its memory writes or reads. So there's actually hardware memory protection on the computer. And if the hardware says you don't own that memory, it's the page manager, the memory manager unit, you get a signal back to your program and it will stop and it will say segmentation fault. And I have to create an example that actually segfaults, and I must confess I didn't practice it. MRB set inv. So those are the steps that you may be familiar with. And we're going to go to ProtoDUNE Anna tutorial. And cluster counter 3 module. And that was the one that, if you followed the instructions, you had added a histogram to it. So Phil, I'm going to look for the fill. And what I'm going to do is try to do something that segfaults. So let's int pointer equals 0. Pointer equals 0. There you go. So what that does, let's set it to 6. Why not? So what that does is I now have a null pointer. So the value of pointer is 0, and I'm going to try to write the number 6 to the memory location pointed at 0, so at the 0 memory address. And I'm pretty sure that I don't own that because a null pointer is a typical error if you forget to set the value of a pointer to something, which is one reason why people say if you can avoid using bare pointers, do it, because that's the way of making segfaults. Install J16 since I'm on the build node. So the first time you run the build, you have to do mrbi. And what that will do is that will process all of these cmakelist.txt files. In fact, maybe we should look at the cmakelist.txt files. And what cmakelist.txt is it is a operating system independent way of specifying makefiles. And my recommendations is just to copy the examples in existing cmakelist.txt files. Look in LArSoft, look in DUNE TPC. You need instructions. If you add any module or source code to your directory here, you have to tell the build system how to build it. And things like art plugins have special simple plugins. This is a really old example. We have newer ones where we have art make macros in the cmakelist.txt files, which will build everything in there, so you don't have to specify modules one by one. And for the most part, well, this says what to build. That's cluster counter 4. Here's cluster counter 3. It says it's an art module. And all of these things are library specifications for things that we want to link with it. So that has built. And we're in this work directory that I didn't PWD in the demo, but you can PWD where the setup script actually points us to. And then we just did lar. I need an input file. We actually still have that. So here's that script. So history is a very nice command to see what you did a while ago. And here is the command that I did. And let's see if it's segfaults. Yeah, yippee! I got a segfault on my first try.
This is perhaps the most joyful moment that someone is having a segfault. Usually you will hate this, but this is done on purpose. Okay.
You're supposed to omit other words from your mouth when you see that, but I'm happy that I got a segfault.
Tom, this is recorded. Be careful.
Right. Let's see. So actually, if you read the tech documentation, it says that how you pronounce tech, or LaTeX is supposed to be pronounced kind of like it. If you pronounce it correctly, your computer screen is supposed to get a little moist. So let's run that debugger. And I saw that, yeah, well, let's go ahead and do that. DDT which lar, and we explained why you need to do this because DDT is too stupid to find the lar executable. And yes, my DDT is old. Let's run it anyway. And DDT is actually pretty nice because it'll remember old breakpoints. So that's the one that we had from yesterday. I'm going to disable it. Input output, and I'm just going to run it because it will stop automatically on the segfault. I think I had the default breakpoints set so that, oh, there we are, stop on the board. And throws and catches, it turns out there are lots of throws and catches in various things. Some people use throw and catch as part of the normal operation of their program, and that makes stopping on throw and catch in the debugger full of noise, and it's hard to find the one you want if people are using it for other things. Ah, great, hit my Segfault. Null pointer dereference or unaligned memory access. Gee, that sounds scary, but I kind of knew it was going to be a null pointer access there. So in fact, I can even look at, that was a right mouse click in the bottom window, pointer. So I named my pointer because I wasn't very creative. So there it is. Null pointer is access that's 0. So that's how you would find it, because when you hit the Segfault, it just printed out the message segmentation fault, but didn't tell you where. When you get an exception from something, you usually get a message that tells you what the exception is, what the problem is. But a Segfault just dumps your program unceremoniously and doesn't give you any context, no traceback, no nothing. But at least you can look at the stack window over here to see, oh, I'm in cluster counter 3, and oh, here I am at line 123. And if you're still confused about why, so this is pretty obvious because I declared the pointer and set it to be 0, and it's pretty obvious what the problem is, but it may not be completely obvious how it got to be that way if that wasn't intended. So if you have a pointer that was computed from something else and you can't tell how it got computed, what you can do is in the program that stopped on the Segfault, you can set some more breakpoints. Let's do this. So a couple of breakpoints and say, I want to go backwards. I want to see what happened before my segmentation fault. I want to step through and go through some calculations that may have set this pointer to be 0 in ways that I didn't expect. But my program has already gotten past that. I want to go back in time and figure out what happened there. So what I would do is I would restart the session with these breakpoints set, restart from beginning, start from scratch. And then I'll hit my breakpoint before it segfaults, and then I'll be able to backtrack what it's been doing. And the stack can be useful here because the stack will tell you what's called the methods. And this is especially useful if this is not your code, but somebody else's code. And you want to know, well, there's this mysterious segfault, and it may be the caller that made invalid arguments for the callee, the call routine. So we're starting over from scratch, and you need to control random numbers. If you are running something that depends on a random number that's seeded with the system clock, you may not get the same segfault every time. And then it's very hard to debug because it might succeed. So it's a lot easier to debug something that crashes consistently. And then you can go back and rerun it and try to see what happened before the crash. So here we are, we haven't crashed yet. And in fact, I could step through this, or I could just say, play whatever. Oh, we want to go through some of this. So let's step. This is stepping over. Whoops, we stepped into something. We got the number of hits. This means step into a method. This means step over, regardless of whatever's in there. So if I step into this, and this is an issue that I had before making the video, is that I tried stepping in, but I didn't go into this SumADC method. I click step in again, and I still don't go into the SumADC method. And I blame this on the fact that the program has to evaluate this thing first, the argument, this at operation on this vector has to check its argument I against the limit. So in fact, a vector access, you can use square brackets like an array, or you can use the at method. And what square brackets will do is it will just act like an array and compute an offset from the beginning and give you the value. And that can segfault if you run off the end. What at will do is it will check against the maximum size of the array. And the array can grow to the size that you need. If you push back more data on it, the vector will get bigger. And at will always check the reference to make sure that it doesn't segfault. Or if it does, if you do try to go off the end, you get an exception, which you might not think is any better than the segfault, but it'll unwind the stack. Someone may be able to catch the exception, print out a message, and you might have an easier time with an exception than with the segfault. Okay, everyone okay with that? Oh, and I was going to step into that method because it took like 3 tries to get into this method. Oh.
You got some thumbs up in case you don't see them.
Okay. There we go. We finally got into the method. And then you can step over this. Oh, I don't know why it stepped out. So this is one of the problems with debugging the prop version optimized code, because I had wanted to just step one statement and it bounced out of my method, and I didn't intend for that. That probably wouldn't happen if I was debugging with the debug build. Okay. So that's how to find a segfault and what a segfault is. Oh, we should tell people what the heap and the stack are.
Yes.
Okay. So the stack is memory that is allocated by first in or last in, first out principle. It's like a stack of plates. So what there are actually machine instructions that push and pop things on the stack, and there's a special stack pointer for memory that's on the stack, and it's usually allocated starting at a particular position in memory, and when you push things on the stack, you get some memory to put that thing, and it's always at the end of the stack. So you can push more things on the stack and the stack will grow, and pop things off the stack and you release this memory on the stack and the stack will shrink. And this is useful because a program that calls subroutines and methods and functions and things needs to know where to go back to when the function is done. So the list of places to go back to when your function is done is called the call stack. So not only does it have return addresses to go back to, but it also has the values of the arguments that you call a method with. So when you call a method, you put the arguments on the stack, and then you put the return address on the stack, and then you go into the new method. The new method has local variables like the ones in our module. Oops, so we don't let's see, make list.txt file. So local variables like that pointer that we had, these are private members. They're actually not on the stack. So fn, oh, that's a private member. So I, the loop counter, this is on the stack. So whenever you declare a variable that's local in your method, it gets pushed on the stack too. And you might ask, why is that? Why would you want to pop off variables from the stack when your method ends? And the reason is recursion. So methods can call themselves, and if someone has a variable in a method, you want a new one every time the method calls itself. You want it to be fresh and have all new local variables, because then it'll not trample on the caller. So every time you call a method, you should get new local variables. And then when it exits and goes out of scope, the variables go out of scope, then the stack gets popped off and the memory gets released. So the stack is very busy. It's got a lot of things that with return addresses, arguments to methods, and local variables constantly getting allocated and deallocated. So that means there's a lot of garbage on it when things get deallocated. And C and C++ do not clear out memory fresh when you allocate it. If you declare a new local variable or grab some memory somewhere, in order to improve the speed, C does not say clear out initialize it to 0. It just leaves the memory contents the way they were. So if you put things on the stack and don't clear them out, you get whatever garbage was in there before in your variable. An uninitialized variable typically has nonsense bits in it that maybe it was a floating point number before, now it's an integer. If you store the different kind of data in a memory address, it's still valid bits, and can be interpreted as whatever it is that the new variable has, but it will be garbage. You'll see nonsense numbers. So sometimes if you see in the output of your program a crazy number like 10 to the 100, that's probably either a memory overwrite or someone forgetting to initialize things. So the most common value for people to leave in memory just statistically is 0. There are a lot of zeros in most people's programs, and that's the source of null pointers. If I had just declared this pointer and not initialized it at all, chances are it would be 0. But maybe not. Maybe this would actually succeed. I might not get a Segfault sometimes that I run this program. It may give me something perfectly good on some runs and something garbage on other runs. So if you have an uninitialized value memory address, then it will be random. Now it turns out that the compiler is pretty good about this. You can ask the compiler to stop on warnings. And that's what MRB does, is that if there's a warning that the compiler tests for it, oh my gosh, that actually succeeded. So we've got it set to check for uninitialized variables. So let's try to use the standard namespace with std and don't say
Tom, I want to point out that in programming, sometimes you can have a success in the sense that your code is compiling, and also another step of the success is that your code is running, and another step of the success is your code is running without crashing. Okay, but the last step is that people often forget to check is it doing what I want? Right. So there are always this staircase of code. So when you say this, I wanted to add this, like be careful, always check in the very end if your code is doing what you want it to do.
Absolutely. In fact, I would say a program that crashes is preferable to one that doesn't crash but gives the wrong answer. And one of the things that I often get as someone that people go to ask questions is that if someone has a program that they don't know it has a problem and they want me to check it all, it's actually a lot easier to debug a program that has an obvious bug in it. If the program, they're not quite sure it has a bug and people just want to validate it and they want to gain confidence that it's doing what it should be doing, then you kind of have to run it and look at the output, make histograms, go to your working group meetings and show your results, and people say, hey, that looks like garbage, or that looks plausible. And it's really hard to tell the difference between something that is almost what you want and something that is what you want. So I finally got this error of maybe uninitialized. So I tried to print out the value of something that I didn't initialize. And the compiler is set to detect that. And it prints out this warning message that says maybe uninitialized, use of uninitialized value, and that will stop because MRB declares warnings to be errors. So all warnings will be treated as errors, build stops, and then what's in local products, oh, I should show you what's in local products, will be the last build. So there are 3 directories, and I made a 4th one called work. That's where we are here, where we're trying out our program. You shouldn't put big files in the app disk, but I have when my script sets up this area, it creates an extra little scratch area for me to work in. But the 3 directories are the sources, where we were editing the code. There's this build where we were just building the code, and then there's local products. We didn't look at local products in the video. So this is essentially like the UPS area, and it is an UPS area. And for some reason, these files, well, this one, UPS files, is a hidden file, but you can look at it. It's a text file. And this is just a, well, it's a directory. This is a text file, dbconfig. This is just a little boilerplate file that all UPS directories have. And ProtoDUNE Anna is a UPS product. They have them in CVMFS, DUNE products, DUNE. So these are all the DUNE related products, and ProtoDUNE Anna is one of them. ProtoDUNE Anna. ProtoDUNE Anna. And those are all the versions that we have released. And this one in local products is my test version of it that I built from source. And let's see what's in there. Whoops. Oh, okay. So we've got just one version of ProtoDUNE Anna that we built from source, V092202. The .version is just a little stub file that says which versions are available. So I'm going to look at here where the actual code is. So this has a copy of the source, which we distribute with the built objects like shared libraries. We distribute the source so you can debug it. So all these CVMFS directories have source, they have include, they have job, and they have these things that have to do with the flavor. So include. So when the cmakelist.txt files say install headers, and I think there might be an install headers. I don't know if we probably don't have any headers in here. Install headers. So what install headers does is it copies things from your source directory, header files.h files, to the local products include directories. And for instance, you'll see headers in there. And the reason we install the headers in CVMFS and your local products is so that people can build their products based on the installed versions of, say, ProtoDUNE Anna. Now, nothing depends on ProtoDUNE Anna, but someday someone might create something that does. But all the products in LArSoft have header files, and if you want to build some software on top of LArSoft, you need the headers, so they have to be installed. So they're headers and include. Job has fickle files. So you see all the fickle files that were installed by install fickle. They're put in job. They have to have unique names or MRB will complain. And the source, that's just a copy of the source directory without the cmakelist.txt files. And the interesting directory is this one, SL7, the flavor ones. And bin is for executables. So some people put precompiled non-art executables. So if you make your own executable in some of these, you can install them in bin. And cmakelist.txt file shows you how to do that. And lib is the place where most of our built programs go. So if you compiled something, you get these shared object libraries. They're the equivalent of DLLs or dynamically linked libraries on Windows, or DY libs on Mac OS, and they're called .sos in Linux. So these names are the names that Art needs in order to load up a module. Is they've got the prefix lib, and then the a string saying what the product or the directory name ProtoDUNE Anna. So some of these, there should be a tutorial test. Do we have any tutorial test? Where did cluster counter 3 go? Oops. There we are. Lib cluster counter 3. So it doesn't actually have, say, a subdirectory name. It just went into it. Probably is because we asked for base name only in here. So a lot of these plugins just have their base name. If you didn't say base name only, then the library would have strings in it from the directory in which it found to distinguish it. But these guys just have the name of the module with lib in front of it, _module.so. So when we compiled our new bit of source, it made a shared object library, and Art has to pick this up. And this is in the LD, actually it's in the set plugin path, echo set plugin path. And I might have to do MRB SLP in order to do that. So let's do it in this one though. Echo set. So So this is the list of places where Art is going to look for shared objects, and this local products library directory is where we want to see it. So if the compile succeeds, what it does is it builds all these SOs in the build directory, and then it copies them and installs them. That install step copies things from the build directory into the local products directory. So if the build fails, this directory won't have the new ones, it'll just have the old ones. And this is done for safety because you don't want to trounce a running program with a non-running version, or break things that were working if you are still experimenting with building your program. But it could be confusing because if you put in a change in your module, like this one, and you make a mistake and the build fails, then this won't update. You'll always have the last successful build in your local products. And if you had no successful builds, then this will be empty. Is everyone okay with that?
We like thumbs up. Yeah, you have thumbs up. 4, nice, great. There is a last question. We have still a couple of minutes. Thank you so much, Tom. There is a last question. So the green window is when your program is written in the C language, and then we're just using the debugger to find any problem in our code. You can have a look at the documents on your other desktop on the person who asked the question.
Mm-hmm. I can't remember if I went over how to find troublesome source, because the debugger generally can't find source files. It can't find them. So these SOs, they contain, oh, here's a dirty trick. I'm going to show you dirty tricks. So let's go back to the local products.
Do you mind explaining what is a dirty trick, please, Tom?
These are things that are undocumented expert sorts of things that we can tell you by word of mouth. There are things on the web. They're not all that bad. So it's not cheating, but it's something that there are tools that aren't necessarily designed to do this, but it's fine. So the strings tool is what I like. Let's see, cluster. And when I don't know the name of something and I don't know if it's capitalized, I use wildcards, and then I skip over the things that I know could be capitalized to use wildcards. And that way I can get things that may have camel case, where you got some things that are capitalized and others not. I just look for the uster part because I knew I was looking for clusters. So let's look for strings in here. What this will do is this will print out the printable strings and not the garbage strings that are at least 4 characters long. And let's grep for instance, TRJ. So what this says is that the shared object module has strings in it that say what the source is. So we edited the source file in the source directory here, and the location of the source file when it was compiled went into the shared object library. So that means the debugger can actually find this source file and be able to load it up and look at it. When we hit the segfault, it was able to show me the line in the source where the segfault was, because it was able to find the source file. However, the installed versions of these products were built on the build nodes. They're called Jenkins nodes. And we've got, right now they only run at Scientific Linux 7. We used to have SL6 and Macintosh. So we would have to build our programs on many different platforms and install them all in UPS. So the locations of the source would be on the build nodes, but then we would copy them, the SOs, into CVMFS. So the build node source is no longer accessible. So the debuggers wouldn't be able to find the source. You would debug some UPS product that's installed in CVMFS, and the debugger would say, sorry, I can't show you the source because I don't know where to find it. But the source is there on CVMFS, but the debugger doesn't know that because it's all been moved. So you have to tell the debugger where in CVMFS to find the source. So then you have to look in places like DUNE TPC. Here is an environment variable that points to CVMFS. So this is one of the products we didn't build. And say proto-DUNE dir should be the local one. We only built some of the code. We built proto-DUNE Anna, but not DUNE TPC. DUNE TPC was sitting in CVMFS and things like LARSoft. That's also in CVMFS. So the debugger won't be able to find source for this, but you can look in DUNE TPC dir or LARSoft dir for source, and you'll find all kinds of source there. And then you'll have to point the debugger at that. So I should be out of time. Or
slightly, but it's okay. It's we forgive you, Tom. That was great.
Okay.
There is something in this question that I'm highlighting right now that perhaps you can give a longer answer than mine in a written form, and then the person will know more. That would be great. I suggest, as it was a lot of material, a lot of tips and tricks, that we take a little break. It's 4 minutes past the hour. Let's reconvene at 10 past the hour. And of course, thank you so much, Tom, for giving us this nice tour and tailoring it to the questions. And thanks so much to the participants to also ask your questions in the live documents. So let's have a bit of a break, 5 minutes, 300 seconds.